These are examples for section 14.4, volume of prisms and cylinders. Example 1. What is the volume of the prism shown below? Remember, volume is what the space inside, and in this prism, the volume formula is V equals big B, or the area of the base face, times the height of the prism. So, starting with big B, which is the area of the base face, in this case is a rectangle, is base times height. So, the area of the base face is the base, which is 24 centimeters, times the height of the base, which is 20 centimeters. Remember, they're perpendicular. Base times height. 24 times 20 is 480. Centimeters times centimeters is centimeters squared. So there's our big B. The height of the prism, therefore, is going this third direction, 10 centimeters. So the height of the prism is 10 centimeters. We have everything we need to plug in here. So the volume is, area of the base face is 480 square centimeters, times the height of the prism, which is 10 centimeters. Multiplying 480 times 10, we get 4,800. Centimeters squared times centimeters to the first power gives us centimeters to the 2 plus 1, or centimeters cubed. The volume of this rectangular prism is 4,800 cubic centimeters. Example 2. If the volume of the prism shown below is 1,008 cubic centimeters, what is the height of the prism? So in this prism here, the volume is 1,008 cubic centimeters. The base, one of the base faces, right here, the length or base is 10.5 centimeters, and its height of the base face is 8 centimeters. And they're asking us for the height of the actual prism. So this is the H we're looking for. Starting off with the volume formula of a prism, we have V equal area of the base face times the height of the prism. And they give us the volume, which is 1,008, so we substitute that in. Equals, and big B, or capital B, is base times height. So finding the area of the base face here, we have 10.5 centimeters times 8 centimeters. 10.5 times 8 is 84 square centimeters. Substitute this in to big B. We have 84 square centimeters times the height of the prism is what we're looking for. Divide both sides by 84, and we're left with the height of the prism is equal to 1,008 divided by 84 is exactly 12. So the height of the prism is 12 centimeters. Example 3. What is the exact and approximate volume of the triangular prism below, rounded to the nearest whole cubic unit? Here we have a triangular prism where the bases are triangles. Here's one of the bases, here's the other one. The base triangle is, all three sides are 8 inches long. So the volume of a prism is the area of the base face times the height of the prism. The base face is a triangle, so the area for that's 1/2 times BH. Here, this triangle right here, we pull it out, and we've got 8 inches by 8 inches by 8 inches. The base of this triangle is 8, so little b is h. If we draw a height, this is an isosceles triangle, it's equilateral, but it's isosceles. We draw our height. Not only is this a height or altitude, it also bisects the opposite side. So now we have a right triangle that's 4 inches, one of its legs, and the hypotenuse is 8 inches. The height is what we're looking for. So since we have 2 of the 3 sides of this right triangle, we can use Pythagorean theorem. So by the Pythagorean theorem, we have the hypotenuse, 8 squared, equals h, one of the legs, squared, plus the other leg, 4 squared. 8 squared is 64, equals h squared, plus 4 squared is 16. Subtracting 16 from both sides, we get 48 equals h squared. Solving for h by taking the square root of both sides, we get h is equal to the square root of 48. The square root of 48 factored, we get 16 times 3. Simplifying the square root of 16 is 4, and the 3 remains under the square root. So the height is 4 root 3. 4 root 3 inches. Now we have what we need up here. So the big B is 1/2 times the base, which is 8, times the height of the triangle, 4 root 3. 2 and 8 are divisible by 2. 2 goes into 2 once, 2 goes into 8 4 times. Now we have 1 times 4 times 4 times root 3, or 4 times 4 root 3. 4 times 4 is 16, so we get the area of the base face, the triangle, is 16 times the square root of 3 square inches. So the area of each base is 16 root 3 square inches. Now that we have B, we need the height of the prism. The height of the prism is from base to base, perpendicular, which is 10 inches. Now we have everything we need to substitute in here. So the volume is big B, which is 16 root 3 times 10. This gives us 16 times 10 is 160 times the square root of 3 cubic inches. This is the exact volume of how many cubes will fit inside this prism. The approximation, take your calculator, put in 160 times second square root 3, and then enter, and you'll get about 277 cubic inches, rounded to the nearest cubic inch. Example 4. What is the volume of the cylinder in terms of pi and the approximate volume rounded to the nearest cubic centimeter? Here we have a cylinder, the base, with a radius of 3 inches or 3 centimeters. Here are the two bases, here and here. The height between the two bases and perpendicular to them is 8 centimeters. So for volume of a cylinder, we start off with the volume is the area of the base face times the height of the cylinder. Defining the height of the cylinder, height is 8 centimeters. Big B, or the area of the base face, since it's a circle, is pi times the radius squared. The radius here is 3 centimeters. Substituting this in, B is pi times 3 squared. Then we get 3 squared is 9 pi. 9 pi square centimeters is the base area of this cylinder. Substituting in these two things that we need, volume is equal to 9 pi square centimeters times the height of the cylinder, 8 centimeters. So 9 pi times 8 is 72 pi. Centimeters squared times centimeter to the first is centimeters to the 2 plus 1, or cubic centimeters. The volume, exact volume of this cylinder is 72 pi cubic centimeters. Taking a calculator, coming up with the approximation rounded to the nearest cubic centimeter, 72 times pi is about 226 cubic centimeters. Example 5. What is the approximate volume of the bullnose aquarium to the nearest cubic inch? Then find the approximate volume in cubic feet. Here we have the bullnose aquarium in its shape. Notice that if we were to cut off part of the prism part of this, right here, we have exactly half a cylinder. So we're finding the volume of a prism plus the volume of half a cylinder right here. And here's a picture of them separated. And so we can start with the volume of the composite is the volume of the prism. And then we add to that the volume of the cylinder, but only half of it. So 1/2 times the volume of the cylinder. Here's our general formula. The volume of a prism is B times the height of the prism plus 1/2 times the volume of the cylinder is also B times the height of the cylinder. These two H's may or may not be the same. Next, let's come over and let's see if we can define some things that we need. Notice that it's 48 inches all the way across from here to here. We already know that in the prism the height is 24 inches and this depth here, or this length, is 24. And all we need now is how far it is from here to here. Notice that since this is 24, this is 24 from here to here. That would be the diameter of the circular part of the half cylinder. And so halfway would be 12. So radius is 12 here. 12 inches. That's 12 and that's 12. That means that's 12. So if that's 12, from here to here is also 12. 12 inches. So that's our radius. That length from here to here, therefore, would be 48 minus 12 inches. And then 48 minus 12 is 36. I'll come down to this one. So this is 36 inches from here to here. 12 inches from here out to there. This is 24, our height. 24 this way. And of course our radius, we've already said, is 12. So defining all our variables, we already have the radius for the half cylinder. For the prism, we've got our prism. The base part of it would be down here. It's 36 by 24. This is 24, so this is 24. 36 and 24, so the base is 36 inches, and the height is 24 inches. And in the prism height itself is also 24 inches this way. So here's everything we need for the prism. Back over to the half cylinder, the radius is 12, and the height of the cylinder happens to be the same as the height of the prism. So the height of the cylinder is also 24 inches. So this was for the cylinder. Now we have everything we need. And so big B is base times height, because it's a rectangle, the base of the cylinder part, or the prism, times the height of the prism plus 1/2 times big B. B this time is the area of a circle because it's half the cylinder. So half of pi r squared, area of a circle, times the height of the cylinder, which again is 24. We'll put that in a minute. So this would be a formula, detailed formula you could use. Now we substitute in our values, and base times height, the base face of the prism, 36 times 24 times the height of the prism is also 24, plus 1/2 times pi times the radius, which is 12, squared, times the height of the cylinder, which is also 24. There's the plug-in step. Now solving the math and calculating, we have 36 times 24 is 864 times 24, plus, and then 12 squared is 144. So we have 1/2 times 144 pi times 24. 864 times 24 is 20,736. Plus, we can take 1/2 of 144 or 1/2 of 24. I'll use the 24. 2 goes into 2 once, 2 goes into 24 12 times. Now we have 144 pi times 12. So we get 20,736 plus 144 times 12 is 1,728 pi. Now this right here would be the exact answer if they had asked for it in cubic inches of this entire bullnose aquarium, the water that could fill it up. Next, we need to get cubic inches into cubic feet. And so, before we do that, let's find the approximation of this. In your calculator, put in 20,736 plus 1,728 times second pi. You should get about 26,165 cubic inches. Then, finding it in cubic feet, if we want to be the most accurate we can be and most precise, we're going to use this answer since it's exact. So taking this answer, we write it 20,736 plus 1,728 pi cubic inches. We want to change cubic inches to cubic feet. So we use the fact that there are 12 inches in 1 foot and set up a conversion factor as a ratio. We need inches in the denominator so that they will divide out. So we put 12 inches in the denominator. We put 1 foot in the numerator. However, if we canceled out the inches now, we'd still end up with square inches up here. So we need to cube this entire factor, which means we cube the 1, the foot, the inch, and the 12. So we get 20,736 plus 1,728 pi cubic inches times 1 cubed is 1, feet cubed is cubic feet, 12 cubed, 12 times 12 times 12 is 1,728, and inches cubed is cubic inches. So this is our new conversion factor now that we cubed it. Now the inches cubed will divide out, and we're left with this times 1 cubic foot divided by 1,728. So 20,736 plus 1,728 pi cubic feet now divided by 1,728. So in your calculator, to get the approximation, Put in 20,736 plus 1,728 times second pi, then hit enter. Then leave that in your calculator and divide by 1,728. You should get approximately, rounded to the nearest cubic foot, 15 cubic feet of volume. That means you could fill this entire aquarium up with about 15 cubic feet of water. Example 6. If the volume of a triangular prism is 2,520 cubic feet, find the height of the prism if the base face has the dimensions of 14 feet by 12 feet. Well, they tell us that the base has dimensions of 14 feet by 12 feet, and the base is a triangle. So what are they talking about? Well, anytime they do this, and they use the word by, they're always talking about length and width or base and height. So this could be our base, and this could be our height. So on our base face on this prism, this triangle, or that one, the base is 14 feet, and the height that's perpendicular, it has to be perpendicular, is 12 feet. Right here. The other thing that we need to, one of the reasons why we're doing this problem is because if you've noticed, height in a base face and the height of a prism, sometimes, or if you're not careful, you can confuse them two because they both are h's. So one way we can eliminate that confusion is by defining one of the heights as another variable like x. So we're going to start with the volume, since they give us volume. Volume of a prism is big B, h. And we're going to let some other variable, totally different, like x, equal the height of the prism. Of course, the height of the prism connects the two base faces. So this right here would be x. We're defining the height of the prism instead of h, x. Then, when we do that, suddenly we have v equal big B x now, because this is the height of the prism. Now going from here, notice since this is a triangular base, we have the volume. Since the base face is a triangle, it's 1/2 BH. So we take this and put it in here. 1/2 BH, remember base times height, here and here, times x, the height of the prism. Now that we've laid everything out, all the variables, let's go ahead and plug in what we know. The volume is 2,520, so we substitute that in. Equals 1/2 times the base of the base face is 14, times the height of the base face, which is 12, then times x, which is what we're looking for, the height of the prism. And then we start slowly solving this. We have 2,520 equals 1/2 of 14 or 1/2 of 12. It doesn't matter. I'll just use the 14. 2 goes into 2 once. 2 goes into 14 7 times. Now we have 7 times 12 x. 7 times 12 is 84x. So 2,520 equals 84x. Then divide both sides by 84 to solve for x. And x is equal to exactly 30. X was the height of the prism. Therefore, height of the prism is 30, and it's in feet. So this is 30 feet along here. Example 7. Find the length of the apothem of the base of a regular octagonal prism if the volume of the prism is 720 cubic feet. So the volume of this prism is 720 cubic feet. And they said it's a regular octagonal prism. Notice the octagon at the bottom here, one of the bases, and then one at the top. And they mark an apothem here. They want us to find the length of the apothem, or an apothem, so that's what we're looking for. They also give us that the height of this prism is, from base to base, is 9 meters. So from here to here, 9 meters. So we start with the volume formula, V equal big BH. And since the base face is a regular polygon, the area of a regular polygon will substitute in for big B. So we'll go ahead and use it in here. Volume is big B, which is 1/2 AP for a regular polygon, times the height of the prism. Next, we substitute in what we know. We have 720 for our volume equals 1/2 times A, which is what we're looking for, times P. Now P is the perimeter, so we come over and find the perimeter. The perimeter of the base face, it's a polygon, so it's N times S, the number of sides times the length of a side. So the perimeter is equal to the number of sides, which is 8, times the length of a side, which is 4 meters. Length of a side, so 4 meters. So the perimeter of the base face here is 8 times 4 meters, which is 32 meters. So now we have P, we substitute it in here, 32, times the height of the prism, which is 9. Now we're set to solve for A. We have 720 equals, and then 1/2 times A times 32 times 9. 32 is even, so 2 and 32 will divide out. 2 goes into 2 once, 2 goes into 32 16 times, and now we have 16 times 9 times A. So we have 720 equals 16 times 9 is 144. A. Divide both sides by 144, and A is equal to 5. Therefore, the apothem of this prism is 5 meters long. So this is 5 meters.